Okay, we're looking at series circuits here. We're going to do some practice calculations to help you better understand the different rules of a series circuit and how to calculate voltage, current, resistance, and power within that circuit. So the first thing I'm looking at is a series circuit here, and I know it's series because there's only one pathway. If I trace that pathway from one side of the battery to the other side of the battery, I go through one resistor, the second resistor, and back to the battery. This is one pathway. This is a series circuit. It has two resistors, R1 and R2. So because I know this is a series circuit, I've got to know my rules for series circuits as well. And the rules say that current is constant. So current is I. Current is constant. Total resistance. To find total resistance, you simply just add each resistor up. So RT, total resistance, equals R1 plus R2 plus however many resistors you have. Okay, I still know Ohm's law. I know Ohm's law says that V equals I times R, and I know power equals current times voltage. Okay, so if I'm looking at my table here, I see I've got a column for resistors, which is R, got a column for current, which is I, column for voltage, which is V, and power is P. Okay, so we're going to use these rules to help us calculate everything that is missing. So I'm looking at my table here, and it tells me that my total voltage is 30. So this battery here is pushing out 30 volts. Each resistor here has a resistance of 15 ohms and 10 ohms. So R1 has 15 ohms, and I'll label that here on the side. We'll say this is R1 and this is R2. So R1 has 15 ohms, R2 has 10 ohms. So the first thing I like to do is complete either a column or row that has the most information given to me. And I'm seeing that all I know here is voltage, nothing else. But here in my resistance column, I know the individual resistance at R1 and R2. And just like we wrote here to the side, to find my total resistance, I simply add up R1 and R2 plus however many more I have. But in this case, I only have two, R1 and R2. So 15 plus 10, when I add those together, I get 25. So the total resistance is 25 ohms. Okay, so let's see, I don't have any other information down here, but I do have across the row, I've got R and I've got V. I can calculate I because V equals I times R. Okay, if I look at my equation here on the left, Ohm's law, it says that V equals I times R. If I want to get I by itself, I have to divide R to the other side. So if I rewrite it, it looks like this. I equals V divided by R. So if V is 30 and R is 25, 30 divided by 25 gives me 1.2. And I know, according to my rules, over here to the right, that current is constant. So I'm going to write 1.2 all the way down. 1.2 and 1.2. Okay? Let's see. So looking down here in my individual, I've got I've got current, and I've got resistance. Voltage equals I times R. Well, here's V, here's I, here's R. 1.2 times 25 gives you 30. So if I look down here, 1.2 times 15 should give me 18. And then 1.2 times 10 gives me 12. And the last step I need is power. Power is I times V. Well, if I is 1.2 and 30 is V, if I multiply these two, I get 36. And then down here, I got 1.2 times 18 gives me 21.6. And then 1.2 times 12 gives me 14.4. And if I want to double check, 14.4 plus 21.6, if I add them together, gives me 36. 12 plus 18 gives me 30. Current is constant, and 10 plus 15 gives me 25. So in a series circuit, it's pretty easy. If you know what's constant, then everything else just simply adds up. Okay, so if I look down here at my second circuit, I see a series circuit again, and I know it's series because it has one pathway. If I follow from one side of the battery and trace this wire through one resistor, second resistor, and back around to the third resistor, that gives me only one pathway to complete my circuit. Therefore, this is a series circuit. So the same rules apply as above. Okay, current is constant. Total resistance is the sum of each resistor. So let's go ahead and label a couple things. This is R, this is I, V, and P. Okay, and then over here, since I have three resistors, this is R1, R2, and R3. So just like in the previous circuit, I didn't have any other information other than total voltage and the individual resistance at R1, 2, and 3. The first step here is to find the total resistance, and I can find total resistance by simply adding up 8 plus 6 plus 2, and that gives me 16. So 16 ohms is my resistance. Now I have voltage and I have current. And just like we calculated above, if I take voltage and divide it by resistance, I get I. So if I take 64 and I divide it by 16, I get 4. And according to my rules, current is constant in a series circuit, so I have 4 amps all the way down. Okay, next step is to find voltage, V. V is I times R, so 4 times 16 is 64. If I come down here, 4 times 2 is 8. 4 times 6 is 24. And 4 times 8 is 32. And if I want to check my work, 32 plus 24 plus 8 will equal 64. Last step here is power. Power is I times V. If my I is 4 and V is 64, then my power is 256. Okay, down here I've got 8 times 4. And 8 times 4 is 32. Next row I've got 4 times 24, which is 96. And the last one is 4 times 32, which is 128. And to check my work, 128 plus 96 plus 32 equals 256. 32 plus 24 plus 8 equals 64. Current is constant, and 8 plus 6 plus 2 is 16. So let's move down a little bit more. And I've got my last circuit, and I'm looking at the circuit. If I start here on one side of the battery and follow the pathway through one resistor, second resistor, around the corner, through R3, R4, and back, that's only one pathway. This is a series circuit. So I know that current is constant. I know that total resistance is the sum of each resistor, of all resistors actually. Voltage is I times R, and power is I times V. So if I start here with my individual resistors, 220 plus 80 plus 150 plus 50, add it all together, gives me 500. Okay, and I is V divided by R. So 12 divided by 500 gives me 0.024. And I know that current is constant, so 0.024 all the way down. Okay, last step, let's see, or not last step, but the next step is finding voltage. Voltage is I times R, so 500 times 0.024 should give you 12. 50 times 0.024 should give you 1.2. 150 times 0.024 should give you 3.6. 80 times 0.024 should give you 1.92. And lastly here, 220 times 0.024 will give you 5.28. And my last step is power. Power is I times V. So I have I, which is 0.024, times V, which is 12. When I multiply those two together, I get 0.288. Okay, next one I've got I times V, 0.024 times 1.2 gives me 0.0288. And we're not going to round yet just for the sake of our calculations. Our next one is 0.024 times 3.6 is 0.0864. 0.024 times 1.92 is 0.04608. And the last one, 0.024 times 5.28 is 0.12672. And the reason I didn't round is because I wanted to show you that if I add my individual power values up, I will get 0.288. If I were to round all of these numbers to 0.13 and 0.05 and 0.09 and 0.03, when I added those up, I would get something a little off from 0.288. But if I keep all these values and add them up, I get 0.288. And then 5.28 plus 1.92 plus 3.6 plus 1.2 gives me 12. Current is constant. And 220 plus 80 plus 150 plus 50 gives me 500. That's how you do and calculate series circuits.